Today we are going to look at writing linear equations in slope-intercept form. So let's get started. To write an equation of a line, we only need to know two things. So let's see what those two things are. The slope-intercept form of a line is y equal to mx plus b, where m is the slope of the line. So the slope, that's how much this line goes up or down as you move from left to right on the graph. Since it looks at how much the y value changes as the x value changes, the slope is also called the rate of change of the line. B is the y-intercept of the line. This is where the line crosses the y-axis. This point will have an x-coordinate value of 0, since the point is neither to the right nor to the left of the y-axis. It's on the y-axis. And we can test this. If we take this equation and we set x equal to 0, this is going to give us y equal to m times x, now x is 0, plus b. So this term goes away. M times 0 is 0, leaving us with y equal to b. So b is the y-coordinate value when x is equal to 0. When x is equal to 0, we're on the y-axis. So this is where the line crosses the y-axis, and we call it the y-intercept. Now the x and y variables, they represent any ordered pair, so any point that is on the line. What this means is if we know two things about a line, if we know its slope and if we know its y-intercept, we can write an equation for that line. In this case, we have a y-intercept of 3. This is the ordered pair 0, 3. Therefore, b is equal to 3. The slope is negative 2. To write the equation, we plug those values of m and b into this equation, giving us the equation y equal to negative 2x plus 3. We have successfully written an equation for a line with a slope of negative 2 and a y-intercept of 3, and this equation is in slope-intercept form. So let's practice writing equations in slope-intercept form. We can do this if we know the slope, m, and the y-intercept, b, of the equation. So in this example, we have a line with a slope of 1/3 and a y-intercept of negative 2. What is the equation of this line in slope-intercept form? Again, so we are told we have a slope of 1/3. So that means m is equal to 1/3. And our y-intercept is negative 2. So b is equal to negative 2. With slope-intercept form, we have y equal to mx plus b. So we'll plug in those values for m and b. We get y equal to 1/3 x plus a negative 2. And we can rewrite this as y equal to 1/3 x minus 2. Here we have a line has a slope of negative 7 and a y-intercept of 3/5. And we're going to write the equation for this line in slope-intercept form. So what do we know? Well, we have a slope of negative 7. That means m is equal to negative 7. And we have a y-intercept of 3/5, giving us b equal to 3/5. And the slope-intercept form is y equal to mx plus b. So now we have y equal to negative 7x plus 3/5. And that is our equation in slope-intercept form. So in these two examples, we were directly told what the slope was, so what the m value was, and the y-intercept. Let's make it a little bit more complicated. So in this example, again, we are given the slope. So we have a slope of negative 5/6 and a y-intercept of, and then we're given an ordered pair. So there's no difference in how slope is given. So in this example, our slope is equal to negative 5/6. But the y-intercept is presented as an ordered pair. With the y-intercept, you're going to have the x value as 0, and then this y-coordinate value will be b. So here, b is equal to 6. We now have the information we need to write an equation in slope-intercept form. So we have y equal to mx plus b. We know both m and b, so we can write the equation. We get y equal to negative 5/6 x plus 6. Let's try another one in this format. Again, slope is given directly, so we have a slope of 2. That means m is equal to 2. And the y-intercept is the ordered pair 0, negative 11. So we have a y-coordinate of negative 11 and an x-coordinate of 0. So this is our b. So b is equal to negative 11. So slope-intercept form is y equal to mx plus b. We now know both the m and b values, allowing us to write the equation. So y equal to 2x plus a negative 11. And then we can rewrite this as y equal to 2x minus 11. So in these two examples, we were directly told the value for m. We were told the slope was, and then given a number. But the y-intercept was hidden a little bit more. We were given the ordered pair. And then with the ordered pair, b is the y-coordinate for that ordered pair. Let's look at one more situation. Here, once again, we are directly told the slope. We have a line has a slope of 3. So with that information, we know that m is equal to 3. And it passes through the point 0, 2. Now this is a special point. Notice that the x-coordinate value is 0. So this point is the y-intercept. So just like in the previous examples, we are given the ordered pair for the y-intercept, but we're not told that it's the y-intercept. So the value for b is the y-coordinate. So b is equal to 2. We now know both m and b, slope and the y-intercept, so we can use it to write our equation. So we have y equal to 3x plus 2. Now this worked because the point given was the y-intercept. If any other point on the line was provided, we would not be able to use this method to write an equation. One more. This is a similar question. So we have a line has a slope of negative 2/7 and goes through the point 0, negative 5/12. So we can see things like goes through the point, passes through the point, contains the point. Lots of different ways of saying that a line goes through a point. In this case, it's that special point again. We have an x-coordinate value of 0. So this is the y-intercept. So we have a b value of negative 5/12. Our slope is equal to negative 2/7. The slope-intercept form is y equal to mx plus b. So our equation is y equal to negative 2/7 x plus a negative 5/12. And then simplifying it, we get y equal to negative 2/7 x minus 5/12. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. Again, so we're looking at the slope-intercept form of a line. So this is y equal to mx plus b. In the first 2 examples, the y-intercept and the slope are directly given to us. So again, the y-intercept is that b value, so we'll plug that into the equation. And the slope is the m value, which we can plug into the equation, resulting in y equal to 1/4 x minus 8. And with the second equation, again, we're given a decimal for a slope, but we handle it in the same way. We have an m of negative 2.5, so that is our slope, giving us the equation y equal to negative 2.5x, or negative 2.5x plus 10. In problems 3 and 4, again, the slope is directly given, but we're simply told that the line goes through a point, and in both cases, our points have an x-coordinate of 0, so therefore this is passing through the y-intercept. So if it goes through the point 0, negative 1, this negative 1 is our b value. We get the equation y equal to 7x minus 1. And for the last problem, it passes through the point 0, 0. So it's going through the origin. Now when we plug this into the equation, we're going to end up with y equal to negative 1/2 x plus 0, but we don't need to show that plus 0. Leaving us with y equal to negative 1/2 x. Continue practicing writing equations in slope-intercept form, and I'll see you in the next video.